Hello, fellow astronomers. Johnathan here. I'm back at the Besser Museum Planetarium today to talk to you about some more cool astronomy stuff. Today, we're going to be focusing on our once and future North Star, Polaris. We're going to cover how to find Polaris in the night sky, as well as what specifically makes it the North Star. So, to start our journey today, let's head into Alpena tonight, the city that the Besser Museum Planetarium is located in, and take a look at our nighttime sky. Now, our night sky here in Alpena is probably better than most cities here in North America, just due to our light pollution. However, it's still not ideal for astronomical observations. So, let's remove all the light pollution within 50 miles of the city and get a nice clean view of our actual night sky. On top of that, if we're going to be talking about the North Star, it might help if we actually face north. So I'm going to turn the planetarium dome around 180 degrees until we're actually facing towards where the North Star is. Now, the first step on our lesson today is actually finding the North Star. And to do that, we start by looking at one of the easiest to find objects in the entire night sky, the Big Dipper. The Big Dipper tonight in the northern hemisphere is really high up, almost at the very top of the sky here in Alpena, pretty much directly above our head. Now, the Big Dipper is a great starter object to look at because, well, it's got so many big, bright stars inside of it. On top of that, its shape is very simple and easy to memorize. It doesn't take much imagination to actually see what this group of stars is trying to form out. Now, the Big Dipper is useful for finding the North Star, not just because it's easy to see, but also because its end stars, the ones at the very end of the cup, right here, are pointing down directly to where Polaris is located. Essentially, we're going to be taking this line that connects these two stars and dragging it out across the sky about 2 hand widths until we reach our bright North Star, Polaris. Now, the cool thing about this line is that its distance is about the same exact width between your left pinky and your right pinky. So if you put your hands out in front of you at arm's distance and you place your thumbs together and you close your fingers, you can place your left pinky on that second star at the end of the Big Dipper's cup, named Dubhe, and with one eye closed, you should be able to peer past your right pinky and see where Polaris is located. Now, it's not exactly ideal for on your monitor right now, but give it a try next time you're out in the sky and have a clear view towards the north. You'll see that your right pinky will get you somewhat close to where Polaris is located. Now, it won't be perfect. Obviously, everybody's hands are a little differently shaped and sized, but it'll get you close enough, and that's really all that you need, because while Polaris may not be the biggest and brightest star in the entire sky, it's at least the biggest and brightest in its little local region of the sky itself. So, upon getting close to it, our eyes will naturally be attracted to the larger, brighter object, and on that, you find Polaris, the North Star here on planet Earth. Now, Polaris gets its name as the North Star for a couple of simple but interesting reasons. And the first is that Polaris is always in the north. If we take a look at Polaris right now, and then we adjust our gaze all the way down to the horizon line, we can see that it is directly above the northern compass point. And this isn't just a case tonight or at this time of year. It's possible for Polaris to do this all throughout the year, which pretty much means as long as you have a clear sky and visual of where Polaris is, you'll know that you are looking due north here on planet Earth. And it's a bit easier to see how this works with all of the constellations sort of linked together as well. we can see how as the night progresses, getting longer and longer, all the stars and constellations orbit in a giant circle around Polaris itself. And in fact, if you didn't know any better, you'd say that Polaris was a sort of thumbtack attaching the entire sky to some sort of invisible firmament that is directly behind it. But we know a little bit better today. But to understand why Polaris works the way it does, we need to explore a couple of other things first. Next thing we want to talk about, before we get on with that explanation about Polaris, is another trick that Polaris can do with navigation. And to understand that, we need to pull up this big line called the meridian, which is simply measuring the angle of objects in the sky above our horizon line, where 0 degrees is the horizon line itself, and 90 degrees, the zenith, the very top of the sky, is the tallest point in the sky. And you can think about it in terms of a right triangle, which has a straight line sticking at a straight angle in it, to where you would act like that third angle in the triangle itself. Now, as we look at the sky, we can see that Polaris is located in a very unique spot along the meridian. It's located at almost exactly 45 degrees above the horizon. And what this simply means is that we must also be at 45 degrees north of the equator. It's a pretty useful tool to have in your back pocket. And while it may be difficult to get the exact angle from it, it gives you a very well-adjusted idea of where you could be. And we can see this in action by actually moving north ourselves and watching what happens to Polaris as we get further and further north from Alpena. You can see Polaris is rising higher and higher and higher, all the way until it reaches the top of the sky, the zenith, at which point it is now directly above our heads. Now, a cool thing that we can see with this is by turning the constellations and the time on once more. And just like it was earlier, everything seems to be rotating around Polaris. However, since now Polaris is at the very top of the sky, everything just kind of rotates around the sky in general. Nothing rises or sets, it just kind of moves about. In fact, the only objects that ever rise and set at the poles are the sun, the moon, and the planets. And that's simply because they're much, much closer to us than the stars are, so we can see their actual movement on a day-to-day basis. Now, that's pretty cool. Now, this entire time, we've talked about what Polaris can do, but it might have dropped a question into your mind. The question of why? Why does Polaris get to do this? What makes it so unique and special that it is our North Star? Well, to understand that answer, we need to change our perspective from here on the North Pole of Earth to the North Pole of Polaris itself. From the top of our North Star, looking back home, we can see an Earth that is greatly enhanced in size for educational purposes. In reality, if we were actually at Polaris looking back home, we wouldn't see Earth, and it's questionable as to when we'd even be able to see the sun as well, as we're just that incredibly far away from our home solar system. But the point I'm trying to drive home by being here on Polaris is that as our planet rotates, as it naturally moves its day and night cycle about, at no point do we ever lose track of any part of the northern hemisphere on Earth. And in fact, if you look directly at the top of the North Pole, it'll almost be like Earth itself is some sort of giant planetary eyeball staring directly back at you. And that's pretty much what makes Polaris so unique. It's not especially big or bright in comparison to the rest of the stars. It's simply in the right place at the right time for our North Pole to be pointing almost exactly at it. And that's just kind of it. Now, in the year 2021, we have Polaris as our North Star. But that wasn't always the case because, well, Earth kind of moves in a weird, dysfunctional way at times called precession. And precession essentially makes the North Pole point into different places in outer space over a very, very long time. And if we go back in time, 4,000 years ago, we can see what that would look like. We can see how our North Pole is no longer pointed directly at Polaris, but is instead pointing off into space someplace else entirely to Alpha Centauri, Schmuckatelli, whatever star. It doesn't really matter at this point, because all you need to know is that, hey, Earth is no longer pointed directly at Polaris, and as such, some other bright star close to where the pole is pointing is going to be the North Star instead. Now, the reason why Polaris is our once and future North Star is because this cycle repeats. Earth's North Pole does point into different directions over time, but it's a big circle that it rotates on. So every 50,000 years or so, the North Pole will move back and point to the place it was previously. So, while one day we will lose Polaris as our North Star, tens of thousands of years from now, when we're all long, long gone from this planet, Polaris will return and become our North Star once again. Alright, everybody. That's going to be our show for today. Thank you all so much for watching up to this point. I hope you learned a bit about astronomy and our North Star, and I hope you had a good time too. Let me know what you think in the comments below, and if you want to see more of my content in the future, simply subscribe to the channel. That way you get alerted anytime something gets published. Until next time, keep your eyes on the stars.